just don't know if we could get a discount on the advertising side of it.
Oh yeah, not the advertising side, but job listing side. Yeah.
Well, okay, you'll have to explain the difference to me after this call.
All right. Is everyone ready again to continue? Great. So are you seeing my screen? You should see this overwhelming graph.
Yep.
So what you're seeing is on the top of the graph, you see the start of an operating system, one of the first in 1969, and it was the foundation for Unix, what later would become Unix. And what you're seeing is all different. Every little box is a different operating system. One forked, one took code from another, etc., etc. And this is basically the foundation of when we are talking about Linux or Unix operating systems. We're talking about this entire family. So if you look all the way on the bottom, you see that it includes Linux, which is the Linux operating system, which we'll talk about more later today. But you also see Mac OS X, that obviously you heard of, and if you have a proper computer, you're using every day. But you also see things like FreeBSD, which is an alternative to Linux, and a bunch of other things. So all these operating systems have their foundations in the same basic, in the same kernel, which is like the lower libraries, which is all Unix. I think it's pretty impressive to see this and see the evolution of this.
That is cool. I've never seen nothing like that.
So, by the way, you can find this on Wikipedia. You can see the URL here. It's the Wikipedia page for Unix-like. So these are all systems that are based on or use a similar foundation as the first Unix systems. Of course, you understand that Mac OS X has been changed a lot in relation to the original Unix, and compared to Linux, they are not the same at all. But they all share the very foundation. And one of the things that they share is how you work with the terminal. So in both cases, you can go to the command line and enter commands, and they share a core set of commands. And this, when you're talking about these kind of systems, you know that you will always have this terminal where you can execute all these commands and where you have access to all these same tricks. So if you know how to work in one on the command line in Mac OS X, you know for a large deal how to do it in Linux, and you can switch your tips and tricks between those two.
Joe, just curious.
Yeah.
Do you know if the B in BSD stands for Berkeley?
Actually, I do not know by heart,
Okay.
but I have
feel
the
like
page
it's
open here. I believe that it did in the past, and then they decided to just not use it anymore, something like that. It's possible that I remember it happening with a database like that, but I'm not sure.
Gotcha. Thanks.
So notably missing from here is Windows. Windows is not based on Unix. So if you're using a terminal or something similar, or Windows Server, it's different. It works different and it feels different. You see that often system administrators or developers put on their resumes that they are familiar with Unix, and others put on that they're familiar with Windows Server, for instance, which they don't really share commands, and they are not really compatible with each other either. By the way, this also doesn't imply compatibility. If something works on Linux, doesn't mean it should work on Mac OS X.
Quick question, Jan.
Yeah.
So those baseline items, I noticed like the HP UX and the FreeBSD lately, usually that's the first question I get from like an inbound lead saying, can you integrate with this? So that's like step one for them to assess GitLab, right? If they can even use it or install it on their system, correct? That's like the first step they have to see if it. Okay.
Yeah.
And we're compatible with all those, or just a few of them?
Sorry?
We're compatible with all of those, or just a few of them that we're not compatible with?
So I'll go into my story and it will explain. So the main thing people run on servers is Linux. So that's the main thing. The reason for that, there's many reasons. One of them is open source. Another is it's completely free. There is another one, which is there are many varieties of this. So Linux is basically the kernel. It's the very foundation. Like let's say if it was a house, it was the foundation and the walls. It's just that the interior, it changes. So you might know Ubuntu. Ubuntu is a flavor of Linux, and the most popular one, where the furniture inside the house is really, really pretty. It might not be the best furniture, but it looks pretty nice. Basically, the IKEA of Linux. There's others like Debian. Debian is maybe not a good example, but Red Hat. You have several small ones like Minix and Puppy Linux. There are hundreds. Many of them are free and open source, and they all share the same Linux foundation. And usually software that runs on one Linux distribution will run on another. The difference is only the furniture that's inside and the dependencies and other software that it brings when it ships. So GitLab runs on almost all Linux variations. So we run on the big ones, that is CentOS, Ubuntu. We run on a bunch of forks and spin-offs of those. And that is what GitLab runs on. And why we run on those is that it will cover pretty much 95% of the market, if not more. Almost all enterprises use almost exclusively the big Linux distributions on their servers, unless they use Windows, which happens if you have other infrastructure or other type of code that you're interested in running on your servers, then you need the Windows proprietary stuff. That is not free, and that is also not open source. Because Linux is open source and free, if a big organization does not have it running, I mean, the chance is pretty much zero. If they have servers, they will have one of these distributions running. But if they do not, they can, because you can just download it and install it. And with modern cloud tools and such, it usually comes pre-installed, and you can quickly set up a server like this. So it's free. So there's not really a good argument for not using it. Although you hear that, for instance, Oracle has its own distribution, and you have these big paid Red Hat distributions or really specific distributions. And sometimes big enterprises, they decide to specifically use that so that they know always what to support and what to count on. That can happen. And in that case, sometimes we can make GitLab work for it, because sometimes it just does, and sometimes not. It's a case by case. But in almost all situations, GitLab will run because everyone uses the same distributions.
So GitLab does not run on Windows Server?
No, and we're never going to do that. These dependencies, so GitLab is a bunch of software that we wrote, built on top of a bunch of software that other people wrote, built on top of this huge legacy amount of software. So that huge bottom, that is simply not available in Windows. Probably you can make it work, and in a bit we'll talk about something that will actually make it work, but GitLab itself you cannot put on Windows. So much for operating systems. Are there any questions about this? All right, back to speak.
Quick question.
Yeah, go ahead.
What would be the market, enterprise market that uses Windows? Is it pretty small? Like, is it just Microsoft, or are there other big companies that use Windows?
No, there are several big. I think there are many big companies that are using Windows, and probably all big enterprises, all big organizations are using Windows somewhere. There's various reasons for it. For instance, if you write software in particular languages or using particular frameworks, it will only work well on Windows. The same goes for types of databases. Certain databases prefer to be ran on Windows, of course, Windows own database. So it depends a bit on your reasons. But Windows Server is really big.
So that's a red flag then.
What?
Right. So that's a red flag for the sales team then, if a company is strictly Windows based, if we find that out in an email or something like that.
Yeah, but I don't think there's ever going to be a company that will say, no, we're not interested in running a Linux distribution. Every company will be able to do that. I highly doubt it, and otherwise it will not keep up in the market at all. So expect that companies that run Windows will also be able to run this on a Linux machine. Otherwise, we can help.
Do we have any integrations? Do we have any integrations with any of Microsoft's development tools like Team Foundation Server or any of their like Visual Studio stuff. Like, so if a company, to Phil's point, still was kind of embedded it with Microsoft, would there, still be kind of a good play there as far as, integrations or, making the bridge?
Yeah, we don't have any specific integrations. I know that Visual Studio has Git plugins, and they work with GitLab like they would work with any other Git clients. But we do not have any specific integrations with Microsoft products. I mean, we could make it in theory, but we don't have it.
But they could still do it, with the plugins like you just mentioned.
Yeah, they can use GitLab. That's not a problem. They can use any Git tool for that matter. So it's not like it's one of our strengths, but they can use GitLab, yeah.
Cool, thanks.
Actually, GitLab is used at Microsoft. So that should tell you enough.
Right, yeah, I did see that, yep. I just didn't know kind of in, what way or shape.
Wait, so hang on, now I'm a little bit confused. Does Microsoft have an on-premise installation of GitLab on a server that runs Windows servers?
No.
No. There's a team using Linux, and they got the approval to run GitLab.
Got it. That makes more sense then. Okay.
And probably Microsoft here and there in the infrastructure are also just running Linux machines with standard open source Linux software, because sometimes that's much easier to use, like always. Okay, so much for operating systems. Operating systems, you have to put them somewhere. So where do you put an operating system? Well, you put it on a computer, on a server, and that sounds really logical, at least to me. But nowadays, there's the concept of having a computer that runs a single operating system that does stuff is a little bit outdated. So I'm sure you've seen the pictures of big warehouses like at Facebook, or the pretty ones at Google, where you see hundreds and hundreds and hundreds of machines, or like big closets full with stacks of computers. So I'm not sure. Do you have, Phil, do you have any idea of how they manage it there, or how that works?
How the servers work?
Yeah, how is
computing
it possible that they can run many things on that? Is it, if you open Facebook, is there a single machine spinning for you?
Oh, I have no idea, man.
Maybe it was not a good question, but what I'm trying to say is that in the past, we had a big server, which was a big machine. Actually, for GitLab.com, we did this like a year ago still, where you had a single computer, like the computer you have at home, and we would install an operating system on that, and on that, we would install GitLab. So this is fine if you have either not a lot of computational power that you need, so you only need a few requests, or you don't need to do a lot of number crunching, and yeah, if you're not going to expand beyond that. But once you start to put more computers next to each other and you start to do more ambitious things, you want to be able to allocate resources of those computers more flexibly. And what I mean with that is that if you have a really small application, for instance, that does something really, really simple, it does not require a lot of computing power. But as a big company, you probably buy 5 times the same computer. And to reserve a single computer for that, an entire single computer for that really simple app that requires almost no computational power, that would be a big, big waste. So and this has existed for many, many years already. So don't think this is something new. But what people thought of was a simple solution, which is they create a layer, an abstraction layer above the machines. So we have 5 computers, but above those 5 computers, we create an abstraction layer. And on top of that abstraction layer, we can build as many virtual machines, virtual servers, I call it virtual machines, as we want. I actually have a little graphic that shows it to you on my screen. All right. So what you see here in the first, I hope you can see, yeah, there we go. So what you see here in the first image is that you have the infrastructure, on which you, which is basically your computers, the computers of the servers that you have running of yours or someone else's, for instance, Amazon's. And on top of that, you put an operating system. And on top of that, you can run your app. And you can run your bins and libs, refers to binaries and libraries, meaning code that you use to run your apps. Now that didn't make a lot of sense when you started to scale up, when you needed more to run more applications over more servers. So they created this abstraction layer. It's called, in this case, it's called a hypervisor. There's other names for it, and it depends a bit on how it's set up. But you have an abstraction layer here, and on top of that, you're able to run virtual machines. So here you see the 3 colored boxes, and each one has a guest operating system. On top of that, the bins and the app itself. So basically what this means is that you have one or multiple computers on which you can run as many as you want operating systems, which you can access, and you can do anything in as you would like. You can actually do this right now. Maybe if you were using a Mac, you might have used a program like Parallels to run Windows. That does exactly the same. It creates a virtual machine, which is an abstraction of a real computer. And in that virtual machine, it runs the operating system, and you can run any operating system that you want. So the operating system that runs inside the virtual machine, it thinks that it's actually talking to an actual computer, but in fact, the abstraction layer takes care of all the work, all the in and the output. So this way, even if you have hundreds and hundreds of computers, you can still make thousands of virtual computers, or only a handful if you need a lot of resources. This was a really important evolution. VMware is one of the biggest players in this field, but there's many others. And most notably, vSphere and the VX products of VMware are really big in this market. You probably heard of this from one of our customers. So GitLab can run in a VM. In fact, GitLab doesn't even know where it runs, because when you put it in a VM, the app doesn't know better, and the operating system doesn't know better that it's just running on a computer. So we often talk about what you need to run GitLab, like in terms of performance, and we talk about numbers of CPUs. So the CPU, the computational part of the computer, is something you can allocate to a VM. So if you have a virtual machine, then you can say, for instance, oh, I want to create a virtual machine that has 3 CPUs and this much gigabyte of RAM. And so what you're doing actually is that abstraction layer allocates a percentage of the total amount of resources that it has to this specific VM, so that when it needs it, it can use it. The alternative is that if it tries to exceed those limits, it doesn't actually exceed those limits. It's also taking care of the abstraction layer so that it doesn't influence other VMs that might be running.
So would you say, real quick, you would say that VMware basically is a software that optimizes your computing power? Is that like an easy way to put it? Okay.
No, I wouldn't say that. So, well, VMware is a company, but the products that they make are virtual machine products. And a virtual machine it's a complete operating system that is abstracted away from the hardware. So we're making the hardware one big block that we do not care about anymore. That is basically what it is. That is, and that's the only thing. From that moment on, we only care about on the VMs that we put on top. So you only have to set up that whole abstraction layer once. You can add hardware, you can remove hardware, that doesn't matter. But that abstraction layer makes sure that you can just create new servers on top. So let's say that we have a warehouse the size of Facebook's, and we have GitLab running and a bunch of other stuff. Or actually, this is what Amazon does, right? So Amazon has a really big warehouse, and it has there millions of servers. And what we can do as consumers is we can say to Amazon, we can log into Amazon Web Services, and we can just say, give me a server. What actually happens is that VMware Amazon's abstraction layer, it allocates a small amount of resources depending on your request and creates a virtual machine for you. And this takes seconds. And then you have a fully closed stuff environment that has all the capabilities as a traditional server as any other computer, but you do not have the burden of having hardware, which can fail. So in this case, if hardware under your machine fails, usually nothing will happen because the abstraction layer will take care of handling that. And you can do this as much as you want. You can create as many different VMs. You can do anything on it that you want. You can write a virus in it and it will not infect the rest of the system because that is how it's made. It's completely isolated from all the other VMs. Does this make sense, Phil?
Yeah, thanks.
Ernst.
A question. So the hypervisor is presumably the name of an abstraction layer product. Is that the product that VMware makes, or is the product that VMware makes another layer between that and the guest OSs?
No, the product that VMware makes is a hypervisor. Hypervisor is that abstraction layer.
Okay, so hypervisor is not a product name; it's a descriptor.
Yeah, I'm not sure who introduced it first, though. It might be that someone like VMware or Oracle invented it, but it's a general name as far as I know.
And now I know that you're going to tell me that this never happens because it would be stupid if it did happen. But does it ever happen where a host operating system is a Windows server and then a guest OS is a Linux instead of the other way around, for example?
So the host operating system, it doesn't always have to be an actual operating system. So it doesn't have to be Windows. It can just be the hypervisor running on top of the things. I'm not sure if there's hypervisors that run on particular distributions or on Windows, for instance. But if you're wondering about Linux versus Windows, one running on top of the other, that totally happens. Irrelevant of what the host operating system of the hypervisor is, you can run anything in the guest OS. For instance, the way we build GitLab for different platforms is that we have just multiple VMs we spin up, and each VM has a different operating system, and there we compile GitLab for that operating system. And you could also do that, for instance, for Windows. Well, we don't want to build GitLab for Windows, so we can't, but you could do that. And it's the same way that we do it with Raspberry Pi. We just spin up a little VM that replicates the Raspberry Pi, and in that we built GitLab. So yeah, Windows is also distributed over VMs like this.
Okay, thanks.
Hey, Jaap?
Yeah.
I think this is the right time to ask this question. If not, you can just push it off. So sometimes we get inquiries from GitHub users that GitHub is limited or has capacity issues when like loading large files, whatever large is, 100 megs or bigger. I don't know what it's going to be.
Yeah.
Why is that, or why do we not have issues? Is it kind of like built because we have these virtual machines? Just curious on kind of why GitHub may have issues, and if we do not, why we do not.
So the performance is really hard in Git because Git is made to handle text files and not large files. That's why we have Git Annex, and that's why GitHub is working on Git LFS, which we will also support hopefully in 8.1. That is one of the reasons. So Git is just really slow with that. The reason that we can handle that is because we say we have Git Annex, and GitHub is not actually already, they do not offer yet the product Git LFS to their customers to solve this problem. And other performance issues related to between GitHub and GitLab. So if you're buying GitHub, it ships in a VM. So you get this whole VM. That has an advantage for them because they can control the entire environment. Basically, they're saying, this is the house that you're getting. We already put the electricity and everything in its place. Please don't move the furniture. And with GitLab, we're saying, well, this is the furniture. You can put it in any house that you want. And if you have a really big house, then okay, you put it there. You have a lot more space, so it will work better to handle big files and these kind of things. It's a really abstract way to explain it. And as far as I know, GitHub doesn't do high availability very well. And high availability usually comes down to running over multiple VMs. So we have one GitLab. So you go to gitlab.company.com, but your actual request, the actual computation, is handled in one of many VMs. That is something GitLab can do. And as far as I can know, GitHub doesn't do very well. But specific to files, it's a hard question, and there's not a single answer. Are there any other questions about VMs or anything else? All right. So now we're going to talk about today and the future. So when you have a VM, you have an entire, as the name says, a virtual machine. So everything lives in this little magic box, including the whole operating system. Now, having a whole operating system, that's a lot of the files and a lot of code and a lot of binaries, a lot of things that need to run, and then you put your app on top and then the things you need for your app. That's a lot of things to run. And there were a lot of people that thought to themselves, well, maybe we can make this lighter. So people started to think about containerization, as they say, making little containers, and specifically Docker. And I actually pulled these graphics, except the first one, which I made myself. I pulled them from the site of Docker because they're really clear. So what Docker does is it does the same thing as we were talking about having a hypervisor, but it abstracts away even more. It abstracts away the entire operating system so that you don't have VMs that have inside of them an entire operating system. No, rather, you have little containers. And those containers you just run on the Docker engine. And the Docker engine can run on anything. So any operating system, any type of infrastructure. So you're still abstracting away your infrastructure, but you're also abstracting away the entire operating system, and you're sharing your operating system. So you will need some things from the operating system, so certain parts of the code, which provide basic functionality, things like networking and such. But what Docker does is it just abstracts this away. So the only thing you have to worry about from that moment on is what runs in your application. And the nice thing about this is, so what you do is you put your application in a little thing that is a Docker container. You write a file that is called a Docker file. And in there you specify what you need and what you don't need. And then you have this little container that you can deploy to anything running Docker. And because Docker runs on any infrastructure, you can do this anywhere.
So hang on, so just so I understand properly, so the Docker engine essentially, when you write the Docker file or the Docker, what was the name of the file wherein you essentially tell the Docker engine what functionality you need from it?
Yeah, the Docker file.
The Docker file. So in the Docker file, are there essentially options there that emulate different operating systems? So where previously you would have had to have written your code for a certain operating system, now it's almost like there's a more universal operating system called Docker, and you just have to tell it what features you need of it to be able to function?
Yeah, pretty much. So where previously you would need to have an operating system, and for instance, your app uses a lot of networking technology, then you need to install on the operating system the dependencies for that networking. Now that part is abstracted away by Docker, and you can just say, I want to make this connection here and there. If I have any specific dependencies to my application, I can just install them and ship them with the container, but otherwise Docker takes care of them. The point is, the most important takeaway from this is that you put your application in a container, and it becomes completely agnostic of the underlying infrastructure and operating system. And your infrastructure doesn't need to support all this computational weight for these many operating systems, because the only thing that it has to run is this little container. So two immediate gains: you can take your application and put it anywhere. That's one. And the second is that you do not need to worry about having so much computational power, because you gain a little bit because you do not need to run many operating systems.
So at what point, I mean, why do we not just call Docker an operating system? What distinguishes Docker from an operating system?
Docker technically runs on top of an operating system. Do you think
because
Docker
there's other competitors
allows you to abstract away these things? Someone is asking a question. Ron.
I was just saying because there's other competitors too, so it's just like kind of like a name of a company, not the technology necessarily.
Actually, so it's, well, hang on. So maybe the way I should understand it is an operating system will actually tell hardware what to do, and Docker doesn't tell hardware what to do. So it has to go through an operating system for the hardware to work.
Yes, that's correct. The basics of that. Ron was saying a thing about the competitor. There are competitors to Docker. You have competitors and projects that are aligned. There's now something called the Open Container Initiative, I think that it's called, where they are creating a standard for these kind of containers. Google has its own thing, Kubernetes, that basically does the same. I think the most interesting part of all of this is that you have to understand that when we were at the point that we had physical servers on top of which we installed an operating system, on top of which we installed our application, at that point, if you wanted to add another server or you wanted to redo things, you would have to go through all the steps. You have to make sure that the operating system is there, your dependencies are there, then you install the application. And if you want to do it on another server, you have to do it all over again. When we started to create VMs, we created something that was completely virtual. So a thing you can do with a VM really easily is just delete it and create a new one. And you have to have some sort of way of configuring that. But within a few minutes, you can destroy an entire VM, and you can make a new one. Or you can create something that is called a snapshot, which is an exact picture of that VM at that point in time. And you can easily recreate that given some time. This was a really simple solution, and this is of course really, really powerful, because you can quickly, we have one GitLab instance running, but now we need more computational power, or you could just create 10 more. With Docker, this same thing is possible, but it's even more lightweight and it's even faster. So with Docker, we can easily create many of these Docker instances. We can put them on anything. We don't even care anymore. You have an infrastructure running Docker? Good, it will run our app. Promised, for sure, because Docker is everywhere the same. And we can easily spin up many, many new GitLab instances. And the thing that Docker does really well is it makes this really easy. And that's one. It makes it really lightweight, because all you need is like a small file. And it makes it really easy to handle many of these small containers. And that is something that you need when you're creating complex applications, such as GitLab, that has database and file things and other things, part of the app's web servers. And you can all decouple those in Docker, and then you can easily spin up many, many Dockers to create a really powerful infrastructure, all virtual and all deployable on any infrastructure as long as it supports Docker. So we're now really high in abstraction. Please let me know if you have any questions. Oh, that's great. No questions. So that's Docker. How does GitLab fit in all of this? So GitLab starts out as code. I'm gonna turn off my screen sharing. So GitLab starts off as code. It's just text files. GitLab is written in Ruby. That means we don't have to compile it into something that you can't read anymore by hand. But it's still just code. You put it on a server, and then you have GitLab running. And that's how we started out, and it was in the beginning the only way to do it. So that's like the first step in the process where you have your code running on a server. You could do that on a VM, and that would work. Nowadays, what we do is we make a little package of GitLab, and we basically package all the code and everything in one. So it makes it much easier to put on the system or on a VM. So I think probably 100% of our customers, but maybe it's 99.9% of our customers, they have GitLab running in one or multiple VMs. Usually they just allocate one big VM. Say they give it 8 CPUs and 16 GB of RAM, and they install the GitLab package there. And what happens is that GitLab installs all those libraries and dependencies, and then on top of that the code, and then the code calls those, and those libraries call the operating system. And we have to make sure that we have for each operating system the right dependencies. So what we do with every release is that we check for each of these operating systems whether we have everything. And we use this tool for that, which is called Omnibus, which you always hear us call. So Omnibus takes care of handling all those dependencies for different operating systems. Now we are in the age of Docker, and we have Camille, who's a little Docker genius. And now we also have a Docker image of GitLab. So somewhere we have in a repository, and we have an image there, a Docker image as it's called, which is basically that snapshot that I talked about before, specifically for Docker. And the way Docker is that not only do you have this nice containers, it's all open source and really easy to use. And that makes it nowadays, if you have Docker, if you have a Docker cluster running, if you have an infrastructure in which you can deploy Docker containers, all you have to do is you have to type, I think it's docker get or docker download, and then a reference to us, which is probably GitLab/GitLab EE. And with only that command, will make Docker pull the entire thing of GitLab. And then all you have to do is you have to say, oh, Docker, I want to have this many containers running GitLab. And because we created a file that allows Docker to automatically configure everything it needs, and whether it needs multiple containers or not, it will deploy itself and it will run in your cloud. So if you are running a Docker infrastructure right now, you can install GitLab in a few minutes and it will work guaranteed, because that's the magic of Docker.
Question: do our competitors do the same thing? Have the same functionality?
I don't think they have. They support Docker yet. Technically, probably you can make it work, and probably they have made it work, but they are not advertising it at all. And it's something we can start advertising that we run.
So then to like look at Docker. Sorry, would it be logical then to look at Docker and look at all of their clients and then potentially say, we have a massive competitive advantage if Docker is already their client and they're already using Docker, we reach out to them saying, hey, super easy way to be compatible with your version control through GitLab?
No, I think that's the wrong way around. Docker is bigger than us.
Okay.
And Docker is still young. You must realize that. So the core Docker tool that makes a little container, they say, okay, you're good. You can use that in production. But the tools you have to use around it, they're really new. And on the Docker website, you read, okay, you cannot use this for production use yet. So very big enterprises are not that excited yet with using Docker for these kind of things. You will see a move towards it, and it will be huge, promised, but not yet. And besides that, it might be that Google will win the whole battle with Kubernetes. That's a matter of time. But you can run GitLab in a container, I think, and with Docker, and it's really easy, and it will work well. It's just that the adoption is still lagging behind.
Like, I guess my question was like, let's say Docker has, a list of clients on their website. Let's say McDonald's is one of their clients or whatever. Would it make sense for us to reach out to McDonald's saying, hey, we see that you're a Docker client. It would be a very easy integration with GitLab to, run your version control through Docker. Am I missing something there, or is that like a legit value proposition?
I'm not sure. I'm not sure if that's reason enough to use GitLab. Maybe that's up to Chad. It would be worth a shot, though, especially considering the competitors, as far as I know, do not do it at all. So if they're going all out on Docker, same by the way with Cloud Foundry, which they for sure don't have, yeah, that might be an advantage.
All right, thank you.
So maybe I missed it. Maybe you mentioned this while I was distracted. But does Docker, is it supported by Amazon Web Services and Azure and things like that?
I don't know what Azure, but Amazon Web Services has this magic cloud thing where you can just put your containers there. So yeah, and that's really nice because on a servers like that, it really works like magic. You do not have to manage anything. You can just put it there in the cloud. This is really the next level where we are completely abstracting away any complex things. And as a developer, the only thing you have to worry about is your code. And if that runs, then the rest will take care of itself. It's really nice.
Hey, Jaap?
Yeah.
Were you kind of has a bad reception here, so I just want to clarify something. If a business is using Docker, are they able to use a GitHub, a Bitbucket, anything like that, or is it excluded because it's going to be open source?
No, they are able to use it, but not on their Docker cluster. So if they want to put something like GitHub or Bitbucket on their cluster, on their Docker infrastructure, they can only use GitLab.
Okay. It kind of goes to what Phil was saying. If we've identified businesses using Docker, they're not able to use GitHub or Bitbucket with that. They may use it on the side where something's not Docker, but that could be something to identify a target market.
Yeah, for sure. But there's no big usage of Docker yet. I mean, there's starting to get big companies but no one has all their infrastructure running on Docker yet. Only small companies. But it will come in a matter of 1 or 2 years.
Yeah, but I think it's just like when we do find that someone is using Docker, they tell us like we're the solution for them. So
absolutely. And it will be. I think it will be a nice selling point. But I also expect that GitHub and Bitbucket will come with something. But let's see. They have not been shown to be very flexible in that regard.
Okay.
So maybe an interesting note. A while back, I was in London together with Douwe and Camille, and then we were at Pivotal, who are making Cloud Foundry. And Cloud Foundry is, in part, it does the same thing as Docker. So you also have the containers. They have to give them all different names, but it basically works also with containers. And they already integrated GitLab with their Docker alternative. It adds a little bit more than Docker because it gives you a little bit more options and flexibility in deploying things that are not specifically made for containers. But basically what they offer is the same thing. And that's called Pivotal Cloud Foundry. So we support that as well. But it's basically also containers. And I know for a fact that very big companies are using that. I think IBM is in that space. I believe Coca-Cola, Philips.
So going back, Jaap, you mentioned that GitLab, it doesn't work with Windows as an operating system. However, what I heard you say, though, if the company has Docker, which does work with Windows, then they could work with GitLab.
Yeah, that's correct.
So that is the workaround. If someone uses Windows, is perfect. If they have Docker, plan to get Docker, then it's a perfect fit for GitLab.
Yes, that's correct. It must be really clear though that we're talking about Windows on the server, so Windows servers, and not Windows, the operating system that Ernst uses, because that is something completely different. GitLab will work with that.
Okay, so that's
GitLab
good.
Works fine on my computer.
What?
GitLab works just fine on my computer.
Yes, exactly.
Okay, so Windows operating system is fine, but if there's a Windows server, they need to have Docker for GitLab to work on that.
Yes, exactly.
Got it. Okay.
Yeah, but probably
or they have to have a virtual machine running Linux, right?
Yes, they could do that, or I think in most cases, most organizations have many operating systems running. So at GitLab, we use maybe a handful for our own stuff. We use Ubuntu, we use CentOS in a few cases. I know Jakob uses FreeBSD for something, but that's about it. So for many big enterprises, they use all sorts of things. Depends on what you need it for. And because it's easy to use and free for at least Unix or Linux, most enterprises use a little bit of everything. All right. So if there's no more questions, I think we should leave it at that.
I have one. It's
Sure.
It's related to Git LFS though, just because I think this is going to be really important for the sales team. So
Yeah.
to clarify, did you say that was? I know you mentioned GitHub doesn't have Git LFS as of right now, correct? Or they do? That's their thing, and then we're also adding it in the next release.
Git LFS is still in development. They open sourced the basis of it. So what we're doing is we're implementing a part that will talk with that basis of Git LFS, but it's GitHub's product. So their implementation on their side is much more advanced than ours. However, they are not selling that yet. Maybe they're selling it to some of their biggest customers, but it's completely in early stages. And it goes for us as well, of course, because it's something that's complex and hard to do. Once they release it, their product will probably be more refined, more fancy than ours. But we will support it pretty soon, and we'll be the first to just say to just ship it along with our product. I know that some beta users on GitHub.com are using it.
Okay. So to clarify on that, we will actually ship that, I guess, to the public before they will, or
Yes.
no? Oh,
yes.
wow. Okay.
We'll probably ship it in 8.1.
Right.
But we're still working on that. I'm not sure what the status is on that now. Well, I'm sure that we haven't started yet, but we're intending to ship it with 8.1 as an alpha, as the very first start.
Okay, great. Thanks.
Anything else?
I'm looking forward to the exam on this one.
We have to buy the subscription for Lessonly, Ernst.
Yeah, it's pretty cheap.
Thanks a lot, Jaap. That was awesome.
Okay.
Yeah, thanks a lot.
Jaap, thank you very much.
Jaap.
And then team, if you have not taken the Lessonly stuff, please do. Jaap is not sending this out just for his own health, so it's just to help us understand what we're learning. So please take the time to do the test, the quiz.
And are you going to send out all the answers? I know you answered a couple of them in the last email.
Yeah, I will send all the answers, but I couldn't access the quiz anymore because I thought we would have until today the trial, but they actually cut it off today, so I couldn't access them anymore.
Yeah, so I sent you an email about the subscription, Joop. I think unless there's a cheaper alternative, like a Google form or something,